Okay, for question 6, it says on an August day at 7 a.m., the temperature in Florida is 75 degrees, and at 12 p.m., the temperature is 98 degrees. Find the average rate of change from 7 a.m. to 12 p.m. So, what's given to us are 2 points. So, the first point is at 7 a.m., the temperature is 75 degrees, and at 12 p.m., the temperature is 98 degrees. And we want to find the average rate of change. So notice we have 3 different ways to find it. The first one, we're going to call this x1, y1, x2, y2. It's probably familiar with that with slope formula. So we're going to do slope formula y2, 98 minus 75 over 12 minus 7. That's going to give us 23 over 5, which simplifies to, let's say, 4.6. Okay. Now, the other 2 methods are the same. So you get the same answer all 3 ways. Now, the other one is going to consider the first point as A, and the second one F of A, and the second one B, and this will be F of B. So, if we just plug in the A and B part, this will be F of B, B is 12, minus F of A is 7, over B is 12 minus A is 7. F of 12 is the result of 12. So the result of 12 is 98 minus the result of 7 is 75 over 12 minus 7 gives you 23 over 5, which gives you 4.6. Okay, so same thing, just in perspective. Now the next one uses something H. Remember, H is B minus A. So in this case, H would be B, 12, minus A, 7. So H would be 5. That represents 5 hours later. So the third one says F of A is 7, plus H is 5, minus F of A is 7, over H, which is 5. Basically, the idea is starting at 7 a.m., 5 hours later. Where the other one said 7 to 12, this is starting at 7, 5 hours later. So this ends up being F of 12 minus F of 7 over 5. F of 12 is 98, the result of 12, minus F of 7, the result of 7 is 75 over 5, which gives you 23 over 5, which gives you 4.6. Okay, so all 3, 4.6, 4.6, 4.6. So your sentence would be, if we write this in a sentence, would be the larger here. Okay, the average rate of change from 7 a.m. to 12 p.m. is increasing, because it's positive, 4.6 degrees Fahrenheit. Let's put it for now, degrees Fahrenheit per hour. So we can squeeze that in there. Okay. So the average rate of change from 7 a.m. to 12 p.m. is increasing 4.6 degrees Fahrenheit per hour. Okay. Now, question 7, we're given a function. The relationship between the number of powerboats registered in Florida and the number of manatees killed is given by this function. Okay. Now, what we have is x is number of years, so we'll be clear about that, and f of x is number of manatees killed. So x is number of years, y is number of manatees killed. So we're going to find the average rate of change for the 2-year period from year 5 to year 7. So in this case, A is 5, B is 7, H is the time between them, which would be 2. So if we compare it to our last example, we have 5 comma, we need to figure out what 5 is, and we have 7 comma, we need to figure out what 7 is. So we're going to go ahead and put this function in our calculator. So we go to our calculator, go to y equals clear, and 3.55 x squared minus 30.2x plus 81. So if we put our function in there, Then if you have your table set, just to double check that, hit second window, make sure it's Ask Auto, not Auto, Ask Auto. Then when you go to the table, second graph, delete whatever's in there. If you plug in 5 and 7, you get those results. So 5 gives you 18.75. 5 gives you 18.75. And 7 gives you 43.55. So now we have our points just like last time. So if we use the first formula, f of b is 7, minus f of a, that's 5, over 7 minus 5. F of 7 is the result of 7, which is 43.55, minus f of 5 is the result of 5, which is 18.75, over 7 minus 5. That's going to give you 24.8 over 2, which is 12.4. Then the second one, again, just filling in the formula, f of a was 5 plus 2. So it's 2 years later, minus f of 5, where you started, over h is 2. That gives you f of 7 minus f of 5 over 2, which we've explained that f of 7 is 43.55, minus f of 5 is 18.75, over 2, which gives you the same answer, 24.8 over 2, which gives you 12.4. So in a sentence, this would be a little bit larger. This would be the average rate of change from year 5 to 7 is increasing 12.4 manatees killed per year. So the average rate of change from year 5 to year 7 is increasing 12.4 manatees killed per year. Now, with question 8, it doesn't say use the average rate of change. For question 8, it says use the shortcut method. So notice that it's the same function. This is finding the average rate of change from year 5 to year 7. This one wants to know the instantaneous rate of change, what's happening at year 7. So the shortcut method says we're just going to take the derivative. So if we take the derivative using the shortcut method, that would be 2 times 3.55, which is 7.1, x minus the derivative of 30.2x is 30.2, and the derivative of 81 is 0. And then when I put that in, put 7 into my function, you're going to get 7.1x minus 30, instead of x, we're putting in 7. And that gives you 19.5. So before we put it in, let's check it. So the way to check it would be to go to your calculator, go to y equals. We have the original in y1. We have our derivative in y2, which is 7.1x minus 30.2. And then we can check that derivative in y3 by doing math, number 8 for derivative. If it looks like this, it's x, and then to get y1 in there, because we're taking the derivative of y1, it's vars to the right for y vars, number 1 for function, 1 for y1, push to the right, x. If you have the other form of the calculator, yours says n derivative, and it's waiting for y1 comma x, and you'll get the same result. But the idea is that when we go to the table, second graph, and plug in that 7, notice that y2 and y3 are the same. That means we've done it correctly. So this one in a sentence, instead of the average rate of change, this one's going to be the instantaneous. Instantaneous rate of change at year 7 is increasing 19.5 manatees killed per year. So in this case, the instantaneous rate of change, not the average rate of change, the instantaneous rate of change from year 7 is increasing 19.5 manatees killed per year.